Hello everyone, welcome back. So in previous lecture I explained about the Johnson macrocator, the type of one instrument that is used for comparison. So it is called as comparator, Johnson macrocator. You can see the figure. Then I explained about the reed type mechanical comparator. Now in today's lecture I will explain about the sigma comparators. So sigma comparator is basically a mechanical comparator which provide magnification of very large rate up to 300 to 5000. It consists of a plunger mounted on two flat steel strips, which is the split diagram, and this at a frictionless linear movement for plunger. Then the plunger carries a knife edge which bears upon the face of mounting block of the cross strip hinge. And the cross strip hinge is formed by the piece of flat steel springs arranged at right angle and is a very efficient pivot for small angular movements. The moving block carries a light metal bifork arm. A thin phosphorus bronze ribbon is fastened to the end of forked arm and wrapped around a small drum mounted on spindle carrying pointer. Here you can see on the figure, then this is the vertical slit diagram over which the plunger is mounted, and the plunger is having one knife edge attached over here where there is one fixed block and moving block. With the moving block we have a Y arm, you can see the Y arm, then the driving drum and the pointer spindle. This strip is made of the phosphorus as we discussed over here. It is a thin phosphorus bronze ribbon at the end of forked arm, and as the here plunger displaces, the knife edge displaces and this block will move. So what happens? This Y arm will be moved. So the with the thin sheet, the drum will be rotated and the pointer will move. So this is the complete arrangement of the sigma comparator. You can see easily. Okay. Now any vertical displacement of measuring plunger and hence that the knife edge makes the moving block of cross strip lever to pivot, and this causes rotation of the wire. So the metallic band attached to the arm makes the driving drum and hence the pointer to rotate. So this ratio of effective length of arm and the distance A of knife edge from the pivot gives the first stage of magnification. The effective length of the arm, okay, capital L, and the distance A of knife edge from pivot point. Here knife edge to pivot point distance capital A gives the first magnification, and the ratio of pointer length and the radius of the drum gives the second stage magnification. This is the radius of the drum and the pointer length small. This one is the capital L Vyam. This one is the A from knife edge and the small r and small l of pointer. So total magnification of instrument is given by capital L upon A. Here there is one mistake, into a small l upon r. So the magnification of instrument can be varied by changing the distance capital A of knife edge of tightening or slacking, then adjusting the screw. Okay. So the magnification of instrument can be varied by changing the distance A of the knife edge by tightening or slacking this screw. So here this distance can be varied by tightening or slacking the screw. The range of instrument available provides magnification of 300 to 5000. So most sensitive models allowing scale estimation of order of point triple zero 1 mm to be made. Now there are various advantages of Sigma comparator. First, the safety, as knife edge moves away from the moving member of the hinge and followed by it. Therefore, if too robust movement of plunger is made due to shock load, that will not be transmitted through the movement. Second, dead beat reading. By mounting non-ferrous disc on pointer spindle and making it move in the field of permanent magnet, dead beat reading can be obtained. So non-ferrous disc on the pointer spindle can be used so that no magnetic effect or the dead beat reading can be obtained. Then the error due to parallax is avoided by having a reflective strip on the scale. Then constant pressure. Pressure measuring Contact measuring pressure over range of instrument is obtained by using a magnetic plunger on the frame. Then fine adjustments are possible. It is possible to have fine adjustments. Then there are certain disadvantages. Due to motion of parts, there is wear of moving part. As you can see, there are number of parts, so the wear will be there. Fear of strip drum, the knife edge. It is not sensible as optical comparator due to friction of moving part. Although it gives very large magnification, but as we know that the optical comparator gives the maximum variation, or it can give maximum magnification. So in comparison to that, mechanical comparator have the moving part, so it is not giving the accurate value as the optical comparator. So this is about the sigma comparators. Now well, let us see the advantages of all the mechanical comparators in general way. So all the mechanical comparator are cheaper, they are less costly compared to other amplifying devices. No need of external agency. These instruments do not require any external agency such as electricity or air, as the variation in the output supply do not affect the accuracy. So it does not require any external source of energy. They are self-working. Okay. Linear scale. Usually the mechanical comparator have the linear scale, robust and compact. These instruments are robust and compact in design and easy to handle. Portable. For ordinary workshop condition, these instruments are very suitable and being portable from one place to another place. Then the disadvantages of all mechanical comparator, as accuracy of these comparator are less compared to the optical or electrical comparator. Reason why, there are too much moving parts, so friction is normally there. So friction is more, which reduces the accuracy. Any slacking in the moving part also reduces the accuracy considerably. Also, the sensitive to vibrations. The mechanism in mechanical comparator have more inertia, and this may cause them to be sensitive to vibrations. Then faults. magnified. Any wear, backlash, dimensional faults in mechanical devices used will be magnified. Then limited range. Range is over here very much limited of the instrument as the pointer moves over the fixed scale. Then the parallax error. Error due to parallax are more likely with these instruments as the pointer moves over the fixed scale. So this is the disadvantages of the mechanical comparators. Next is mechanical optical comparators. Now the working principle of the mechanical optical comparator is based on the fundamental optical law. The in this comparator they use this fundamental optical law, and instead of printer edge of shadow is projected on a curve graduated scale and indicate the comparison measurement. So here you can see in the figure, if the mirror is tilted a little bit, so the ray incident over it will be reflected by double of the angle of the inclination. So half the angle we can find the angle of inclination. The optical principle adopted is that when the optical lever, as shown in the figure, if ray of light O to A strikes a mirror, it is reflected as a AB. So this is the fundamental law. अगर कोई भी मिरर ऑब्जेक्ट है उसके ऊपर आप लाइट रे डालोगे तो क्या होगा, वो रिफ्लेक्ट होगी. सो और उसके बाद यहाँ पे हम क्या करेंगे कि अगर मिरर को टिल्ट किया जाए थ्रू an angle alpha, you can see in the figure. So reflected ray of light has moved through an angle 2 alpha. जो यहाँ पे न्यू रिफ्लेक्टेड रे हमको मिलेगी, that will be the A to B over here. So instead of the original path over here, it will be deflected by the 2 alpha, double the angle of inclination. So in optical comparator, the mirror is tilted by measuring plunger movement, and the movement of reflector light is recorded as an image on the screen. So what happens? We can measure the image on the screen by tilting the plunger. Now the construction of the mechanical optical comparator. Here you can see, so in mechanical optical comparator, small displacement of measuring plunger are amplified by the first type of mechanical system consisting of the pivots, levers, and the amplified mechanical movement is further amplified by the single optical system involving the projection of an image. Here you can see, as shown in figure, the mechanical system causes a plane reflector to tilt about an axis, and an image of an index is projected on a scale on the inner surface of the ground glass screen. There is one light source in the mechanical comparator, then there is condenser, index, projector lens, then mirror, pivot over here, then the lever that is for the mechanical amplification, and this one is the optical amplification. So double amplification will be achieved. Sorry. So first the mechanical amplification, which is L2 by L1 by the lever principle. Now if the movement is of plunger is caused the mirror to tilt by angle alpha, then the image will be tilted by 2 alpha. Therefore, the optical amplification 2 into L4 by L3. So the overall amplification of this system will be 2 times L2 by L1 into L4 by L3. So this is about the mechanical optical comparator. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.